Hello everyone. So today's topic is going to be races, and in this particular idea, we are going to learn the concepts about races, which are divided normally into two types. One is linear races, and one is circular races. So let's first talk about linear races. So linear races is basically simply means that people are going to run in a straight line. So there are some concepts that are associated with this. Basically, we have to analyze few statements and let's see what are the interpretations of them. So, for example, the first one says that A gives B a start of 10 meters. Now, let's say you want to explain this to a layman. What does this simply means is that A will let B run for the initial 10 meters and then A starts running. So once B has completed 10 meters, then A starts running. So that's the first statement. Now this same start can be also in terms of time duration. So for example, it says that A gives B a start of 10 seconds. Now what does that mean? So this means that B will initially run for the 10 seconds, and once that has happened, then A starts running basically. So the starts can be in terms of two things. One is distance, one is time. And those are the ways to look at it. The next 2 points that are related to the finish line. So for example, it says that A beats B by 10 meters. Now look at the wordings. A beats B. So obviously, the only time where A will beat B is basically when A has already won the race. So he must be at the finish line basically, and B is still 10 meters away from the finish line. The same thing can be also in terms of time also. So for example, they might say A beats B by 10 seconds. So same story. A has beaten B. So A is at the finish line. That means A has completed the race. And B is 10 seconds away from the finish line. And lastly, there is something called as dead heat. Now, probably this is something that is you guys have not explored yet before. So, dead heat simply means that it's a tie. Both are winners. Both will finish the race together. Both will complete the race together, and both are winner. It's a tie basically. That is the interpretation of dead heat. So these are few things that you need to know as concepts when it comes to linear races. Now let's talk about circular races. Now circular races also have two types. One obviously is that people are running in the same direction, and the other one is that people are running in the opposite direction. So let's first do the idea where people are running in the same direction. So now observe very, very carefully once the race starts and when they start running A and B, for example, when do they meet for the very first time? That will be the most critical aspect of this race. So let's begin the race. Race has begun. Observe very carefully when do they meet for the first time. So somewhere around this point, 1/4 of the lap they are meeting, and this will always be the case, and hence you have to remember it as the concept only. That for first meeting, if both are running in the same direction, the faster runner will always have a lead of one lap over the slower runner. So, for example, if you analyze B's distance, we can say that B has covered entire one full lap and also covered another quarter of a lap. So B has done overall one full lap plus quarter of a lap, whereas A has done only quarter of a lap. So clearly B has the lead of one lap over the slower runner basically. Now once the race continues, again observe very carefully how many times they meet and when they meet basically both of them. So let's continue the race now. So the race has begun, the race has resumed. Observe very carefully when do they meet. And clearly you can guess it to a good accuracy part that they will meet somewhere in the 6 o'clock position, which is around halfway mark exactly. And that's the symmetric point. If we further continue this race, they will now meet for the third time somewhere around 9 o'clock position, which is probably bang opposite to 1 o'clock, which is bang opposite to the first meeting wala position. And then lastly, the fourth and the last meeting happens back at the starting point, which is opposite to 6 o'clock position, which is 12 o'clock, which is opposite to the second position per se, if you realize that. Now, of course, you might have few questions related to this also, in the sense that how do we decide that how many times they meet and which are the points that they meet. So one thing is very simple: the points that which they meet, they are all symmetric points, so they are all equal points basically. So that's the first thing. The second thing that we need to understand here, that is, how do we decide that how many points they meet. So there is a simple framework for that which we'll have to remember going forward now. So for example, for this particular question, we had assumed that the ratio of the speeds for A and B is 1 is to 5. And what we need to understand here is that if it is a circular race and if it is in the same direction, then we have to take the difference of this ratio of speeds. The ratio of speeds is 1 is to 5. If we take difference of 5 and 1, obviously it turns out to be 4, for example. And if the difference is 4, and that is how we come to know that they are meeting in 4 different points basically, and they all should be symmetric points. So the framework is whatever is the ratio of the speeds, you have to take difference of that, and that gives you the answer. Okay, how many points they will meet basically. And obviously, the last question or the last type that you have to also remember as a concept, that is, every last meeting will always happen at the starting point. Every last meeting will always happen at the starting point. So obviously, in this case, it is the fourth meeting. So fourth meeting will happen at the starting point, basically. So every time this happens, same story will be repeated. Whichever is the last meeting, that will happen at the starting point. So in this case, it is the fourth meeting that is happening at the starting point. So these are the things that we need to remember about circular races that are in the same direction. Let's see what happens in the opposite direction. So same story, A and B, two runners, they are gonna run in the opposite direction. Observe very, very carefully when do they meet for the first time. So somewhere in this position they meet for the first time. And again, if you track their distances, so A has covered only this part of the distance, whereas B has covered this much part of the distance. Obviously, if you combine both of them, you would realize that together they complete one full lap of the circle, basically. So together they complete one full lap of the circle is what we need to understand here, and that will be the case every time for the opposite direction for the first meeting. Now again, here how many times do they meet? So simple framework, assuming ratio of speeds as 1 is to 5, so here we have to add them. So if it is going to be opposite direction, we are gonna add the difference, and when you add the numbers, that is ratio of speeds, you get how many points do they meet. So here it is 6 points they meet. And as usual, same story, which meeting happens at the starting point. So always it is going to be the last meeting. In this case, it is the sixth meeting that happens at the starting point, for example. So these are the few things that you guys need to understand and remember when it comes to circular races. Now, let's just simply compile whatever we have learned. So, assuming ratio of speeds is A is to B, assuming A is greater than B, and in the reduced form because it's the ratio, if it is same direction wala circular race, they will meet in A minus B points because we'll take the difference, and every A minus Bth meeting will happen at the starting point. The last meeting always happen at the starting point. And if it is opposite direction, they will meet in A plus B times. That is, we have to add the ratio of speeds, and every last meeting will happen at the starting point. That is, every A plus Bth meeting will happen at the starting point. So those are the concepts that we need to remember when it comes to circular races. Now there is one common formula though, whether it is same direction or whether it is opposite direction, that is time taken for the first meeting. And this idea stems from the fact that we have done something called as relative speed in time speed distance, that is a previous chapter. So similar kind of theory is applicable here also. So we remember that time taken to meet slash cross in case of trains, that is the general formula was separation upon relative speed. But here try and understand this for the first meeting, whether it is same direction or whether it is opposite direction, the separation is always going to be one full lap, which is one entire circumference, and we have to divide that by relative speed. So we have to divide that by speed, and when we divide that by speed, we get the answer for the first meeting. Obviously the things will change in the sense that uh, if it is same direction, then it will be we have to add the if we have to subtract the speeds if it is the same direction, because relative speed is minus there, and if it is the opposite direction, obviously we are gonna add the speeds basically. So the same thing that we have learned in time speed distance, the same thing applies here also, and hence they are relatable as the concepts. Now, moving to the last part of the concept, which is a part of circular race, which is obviously clocks. Now, whenever we talk about clocks, there are few new things that we are going to introduce here at this point. One is obviously it's a circular race between hour hand and the minute hand, and then the circumference is normally calculated in two ways. One is obviously the degrees, and the other one is a minute spaces. So entire clock, the circumference is either 360 degrees full circle or probably 60 minute spaces we can say. And similarly, the relative speed now we have to find out, but for that we need to have the individual speed. So individual speed, if we calculate, so let's do one thing, speed of the minute hand in degrees now per hour basis. So in 1 hour, minute hand covers how many degrees? So obviously 360 degrees per hour, and in minute spaces it is 60 minute spaces per hour. Very commonsensical. You can understand that if you read it clearly and properly. The other one is speed of the R hand in degree per hour. So R hand covers how many degrees per hour? So obviously only 30 degrees per hour, and minute spaces only 5 minute spaces per hour. The R hand basically. And lastly, we have to do all of this per minute basis. So because we have calculated in per hour, we'll have to divide all these numbers by 60 for that matter. So let's divide all the numbers by 60. So for example, 360 divided by 60 is 6 degree per minute. Then 60 divided by 60 is 1 minute second, 1 minute space per minute. Then 30 divided by 60 is half degree per minute. And lastly, 5 divided by 60, which is 1 by 12 minute spaces per minute. So these are the things that we need to remember as the part of the process. Now, moving on, the relative speed will be, because they are traveling in the same direction, it will obviously be difference of both the speeds because they are in the same direction as we have discussed. So that becomes 6 minus half, which is obviously 5.5, which is 11 by 2. And 1 minus 1 by 12 is 11 by 11 by 12, for example. That's the relative speed. Now, if you can remember it directly, that will be great. If not, then obviously you can figure it out in this particular manner, basically. So that's the idea that we need to remember. Now, let's talk about more about clocks. So the first thing is general facts. Of course, 1 minute space is obviously 6 degrees. Then 60-minute spaces is 360 degrees. Then 1 hour is how many minutes? So obviously 60 minutes. And our hand covers in 1 hour only 5 minutes. So obviously minute hand covers 55 minutes more compared to our hands, because the languages use minute hand gains how many minutes over the our hand. So our hand covers only 5 minutes per hour, whereas minute hand covers 60 minutes per hour. So minute hand does 55 minutes more compared to the hour hand. Then the next one, in 1 hour, the hour hand moves dash minute spaces. So obviously in 1 hour, hour hand moves 5 minute spaces, which is 30 degree. And obviously in 1 hour, the minute hand moves 60 minute spaces, which is 360 degrees, for example. Then lastly, 1 minute, in 1 minute, our hand moves dash degrees, which is half degrees, and minute hand moves dash degrees, so it is 6 degrees in 1 minute. Minute hand does 6 degrees. Our hand does half degree. Speed of our hand, degree per minute. You will get the answer. So this means in 1 minute, minute hand gains obviously 5.5 minutes extra over the hour hand, basically. 11 by 2, the relative speed that we have spoken about. So same things, just asked in a different manner. So be careful, don't make mistakes in these types of calculations. Now, the general timing. So for example, the hour hand and the minute hand coincide every dash minute. So obviously they will keep meeting each other again and again and again, and there is a fixed interval in which they keep meeting each other. So for example, so you have to calculate that. So formula is very simple. It is circumference upon the relative speed. If you take the circumference as degrees, then the relative speed should also be in degrees. And if you take the circumference as minute spaces, the relative speed should also be of the minute spaces. So these are the calculations. In both cases, you are going to get the same answer, which is 720 by 11. And when you do that, you get the answer as 65 5 by 11 minutes. 12 6 are 72. Yes, 720 by 11. If you reduce that further in mixed fraction, you get answer as 65 5 by 11 minutes. So this means the minute hand and the hour hand keeps meeting each other every 65 5 by 11 minutes, and that is their standard meeting time. Of course, if they do not meet in this time, then there are obviously two possibilities. So, for example, if they take less time than this, 65 5 by 11 minutes, then we can say that the clock is fast, which is also called as technical terms is gaining time. And obviously, if they take more than this much time, 65 5 by 11, then we say that the clock is slow. The technical word for that is something called as losing times, for example. So these are the few things related to clocks that you need to know as the concept basis. Okay, now moving on to the questions that are related to this. Let's see the first one. As usual, I'll request you all to pause this and try this by yourself and then see the solution. So the first question is, which says A gives B a start of 100-meter in a 600-meter race. If the ratio of their speeds is 5 is to 4, who will win and by how many meters? How do we solve this? So first is what we have to do is A gives B a start of 100-meter in a 600-meter race. What does that supposed to mean? So A will let B run initially for the 100 meters and then A starts running, right? This is what we have learned in the concept. So same thing will be applied here also. Now here they have also given us ratio of the speeds. The problem is that we will not be able to find out exactly as of now that who will win and by how many meters, for example. So the idea here is that we'll have to assume that one of them wins the race and do the calculation and then see what happens. So point is, let's assume that one of them wins the race and we'll check the calculation and see what happens. So for example, let's assume that B wins the race. If B wins the race, so we have to calculate their distance, and speed and distance are directly proportional. So whatever is the distance covered by B is the same distance that is covered by A according to their speeds basically. So since we are assuming that B wins the race, and you can see that if is the word that is used. So now for B to win, obviously he has already covered 100 out of 600 meters. He has to only cover additional 500 meters. So let's assume that he does additional 500 meters of distance. Now let's calculate the distance of A, for example. When we calculate this, and after all the cross multiplication and etc., we would realize one thing, that the distance of A is 625. And what does that mean? So if you understand the positions as of now, A is at the starting line. We are saying that by the time B covers 500, A covers 625 meters, which means A has finished the race because the race track is only 600 meters, and he has gone another 25 meters ahead, for example. So the problem is that this assumption seems like the wrong assumption because the numbers are not matching with that assumption. So that is the reason we understand as of now that this assumption is the incorrect assumption. So that means it is not B who wins the race, but it is actually A who wins the race, for example. So now if A wins the race, same story. Distance of A is at the starting line. If he has to win, he has to cover entire 600. Let's calculate B's distance after cross multiplication, and that distance turns out to be only 480 meters. So now think about this. By the time A covers entire 600, B covers additional 480 meters. So they had asked two questions: who wins and by how much distance, or by how much difference rather. So clearly you can see it is A who wins, and numbers are also matching. But by how much he wins the race? Obviously, 20 meters he wins the race because B has covered overall 580 meters. Initial 100 meter ka start, which is given by A, and then another 480 meters basically. So B has done 580. So out of 600, B has done 580. B is lagging by 20 meters. A wins the race by 20 meters, is what we can say. So as I said, here there is a 50% chance you might start with the correct assumption and you get it right in the first go. And there is equal chance that you might not. And then you'll have to do this same process here. So this is the way to look at these types of questions, which is question number 1, for example. Now, let's talk about the second question. So, the second question says A beats B by 20 meters in a 100-meter race, and B beats C by 50 meter in a 200-meter race, and C beats D by 150 meter in a 500-meter race. By how many meters A beats D in 1 kilometer race? This is what they are asking. The challenge here is different races are given, different runners are being given, and the question is also asked, which is something entirely different. So that means in such cases, we are going to use something called as ratios basically. So when we say A beats B by 20 meter in a 100-meter race, we can calculate their distances, for example. So A covers entire 100 and B covers only 80 meters because A is beating B by 20 meters. Then B beats C by 50 meter in a 200-meter race. So B covers entire 200 and then C covers 150 meters. And lastly, C beats D by 150 meters in a 500-meter race. So C covers the entire 500 and obviously D does 150 less, that is 350 meters for D. Now they were asking about A and D, for example. So to calculate A and D, what we need to do is make sure that first we have distance of A and distance of D as the ratio. So simply what we'll have to do is we'll have to multiply these values with each other. Why have to do so? Because when we do that, what will happen is at least on paper this B and this C will be cancelled off because they are of the same numbers and will be left with few numbers, which is why we are going to do that, which is dA upon dd, that is distance of A upon distance of D. So 100, 80, then 200, 150, and lastly 500 and 350. These are the values. This is 20 fours are 25s are 53s are 54s are 50 tens are 57s are, for example. This 4 further goes off and this becomes 50 by 21. So what does that mean? If it would have been a 50-meter race, then A would have done 50 meter, A would have completed the entire 50 meters, whereas D would have done only 21 meters. But if you see the data, they are not asking about a 50-meter race, they are asking about a kilometer race. And A is beating D, so A is covering the entire 1000 meters. So, how much will be D covering in that particular scenario simultaneously? So, obviously, what we'll have to do is we'll have to cross multiply these numbers. So 50 into x is 21 into 1000. Find out x. So that is 200. Sorry, that is 20. My bad. So 420 meters is what distance D will cover. But again, they are not asking the distance. They are asking by how much A is beating D. So A is covering entire 1000 meter and D is covering 420 meters only. So that means A will beat D by 580 meters. This should be the right answer for question number 2 according to me. So folks, remember something. If at all something like this comes, this is what you need to think. different races, different people, and question ask is also very, very different. So what we have done is we have taken ratios ka help. Multiply all these numbers with each other so that we are left with what we want to calculate, and that then becomes the matter of calculation to get the right answer in this particular framework. So that's your question number two. Hopefully you have understood that. Let's do question number three, for example. It says A and B running along the circular track at the speeds of 56 meter per second and 24 meter per second respectively. So their ratio of speeds is given. If I divide them by 8, 8 sevens are 8 threes are, that's the ratio of the speeds. Find the points at which they will meet on the circumference if they run in the clockwise direction, and A runs clockwise and B runs anti-clockwise is what they are saying. So if they run in clockwise direction, obviously we know the formula. Whatever is the ratio of the speeds, we have to add them. So obviously 10 points they should meet. Sorry, in the same direction we have to subtract them. My bad. So 7 minus 3 is 4 points they will meet. And in the opposite direction, because one clockwise, one anti-clockwise is the opposite direction, we have to add them. So they will meet in 4 points and 10 points respectively. In the opposite direction, addition. In the same direction, subtraction. So 7 minus 3 is 4, and 7 plus 3 is 10 points respectively, which is answer option for question number 3. Very, very simple and straightforward question. You have to only know the formula to get it right in this similar manner, basically. Okay, now let's do the fourth one. What does this say? So it has three different questions that we have. It says A and B start from the same point at the same time, move along a circular track which is 120 meters long at a speed of 5 meter per second and 3 meter per second respectively. If two of them are moving in the same direction, after how much time they will meet for the first time, after how much time they will meet for the first time at the starting point, and if they keep running infinitely, at how many points they keep meeting each other. So these are the things that we need to remember. Now, what to do here? So clearly all the data is given. We can one by one do all the questions. So the first question is time taken for the first meeting. We know the formula. It is circumference upon relative speed, and circumference, because they are moving in the same direction, it becomes difference between the two of them. So circumference is 120, relative speed is 5 minus 3, which is 2 meters. So time will be circumference upon relative speed, which will be 60 seconds. That's your first answer. Then let's talk about the second question, which is very interesting, which says time taken for the first meeting at the starting point. So here you have to understand there are two meetings that are happening in this particular scenario, and the second meeting is the one that will happen at the starting point. So here we basically have to calculate time taken for the second meeting, for which we did not have any formula earlier, but now we can have the same formula that we have done for first meeting wala time. So whatever is the nth meeting ka time going forward, you can say that it is actually first meeting ka time into n, for example. So here we are looking at second meeting because that's the first meeting at the starting point, if you remember. So in short, we are looking to find out time taken for the second meeting. So time taken for the second meeting is 2 into time taken for the first meeting. And first meeting we just now saw is 60 seconds. So second meeting ke liye it will be 60 into 2, which is 120 seconds, for example. And we also know from the concept that whichever is the last meeting that happens at the starting point. So that idea is still there as well. So no changes there whatsoever in that specific regards, basically, which is what we need to understand. Now, moving on, let's talk about the next question, which is very simple. We have already done that. How many points they will keep meeting each other? So obviously it is going to be difference for ratio of the speeds. Ratio of the speeds is 5 and 3. So they will meet in two different points, one at 6 o'clock, one at 12 o'clock. So second meeting will happen at the starting point, basically. So these are your answers to the three questions. That is answer option 4 is the answer. So question number 1 and 3 could have been done very easily. Question number 2 was something that is new for us. But right now, after this instance, we should be able to tackle this as well. Let's look at the fifth one, which says A and B start from the same point at the same time, move along a circular track 120 meters, speeds are 5 and 3 meter per second respectively, if two of them are moving in the opposite direction. So right now they are going in opposite direction and same three questions they have asked. The first one is time taken for the first meeting. The second one is after how much time they will meet for the first time at the starting point, which is very, very important to understand. And lastly, if they keep running infinitely, how many points they will keep meeting. Here you should not do the solving with options because sometimes you can fall prey to that. So always remember to do it correctly unless and until the options are also very, very clear. Otherwise, you'll miss out on learning, which is what would have also happened in the previous one. So again, the first question, first meeting the time, formula remains the same, circumference upon the relative speed. But here, because they are moving in the opposite direction, the relative speed is going to be sum of both the speeds. That is 120 upon 5 plus 3. 5 plus 3 is 8. 120 upon 8 becomes obviously 15 seconds, for example. So for the first meeting, they will only take 15 seconds because they are running in the opposite direction. So time is less because speed is more in that aspect. Then second question, same story, first meeting at the starting point. So here, first we need to understand how many meetings are going to happen. So clearly how many meetings are going to happen? So 8 meetings are going to happen. Why? Because opposite direction, ratio of speeds is 5 is to 3. And 5 is to 3, if we add them, 5 plus 3 becomes 8. So they are going to meet in 8 different points, which is ideally the answer to question number 3. But why we need this? Because they are asking first meeting at the starting point. So clearly, whichever is the last meeting that happens at the starting point. So eighth meeting is the one that will happen at the starting point. So we are trying to find out the formula for time taken for the eighth meeting. And hence we'll use the formula for time taken for the nth meeting. So we know that already it is first meeting a time into 8. So first meeting a time we already know, which is 15 seconds. 15 into 8 gives us 120 seconds, for example, as the answer, as the second question. So again, conceptual clarity is one thing, solving and getting the right answer is one thing. You have to be good at both. That's when only you will start getting such questions. I hope you have understood this fifth one. Let's go to the sixth one, which says ABC, three runners now, same point, they start at the same time, move along the circular track at speeds of 5, 3, and 2 meter per second, respectively. If three of them are moving in the same direction, assuming length of the track is 120-meter, and same three questions, when will they meet for the first time? After how much time will they meet for the first time at the starting point? And if they keep running infinitely, at how many points they will keep meeting? So now here, because there are three runners, unfortunately what you will have to do is you will have to calculate for two runners separately and then see what happens in general. So let's calculate the time taken for A and B. So again, the formula remains the same, circumference upon relative speed. All are moving in the same direction. The circumference will be subtraction of the speeds. So for A and B, it is circumference is 120 and the relative speed will be 5 minus 3, which is 2, which means A and B are going to meet each other in every 60 seconds. What about A and C? So A has a speed of 5 meter per second. C has a speed of 2 meter per second. They are also moving in the same direction. The relative speed becomes again the difference between the two speeds, which is 120 upon 5 minus 2, which is 3 meter per second. And 120 upon 3 gives us 40 seconds as the answer, for example. Now, because we were supposed to find out for all three of them, what ideally should be done now is that take LCM of A and B, and A's value is 60 seconds, B's value is, I mean, A and C's value is 40 seconds. Take LCM of that, 60 and 40 ka LCM is 120 seconds. So all three of them, if they are meeting each other for the first time, the time taken for that will be 60 seconds. Why this is happening? Because different people are meeting at different time intervals. So to combine all of them together, we have to convert them all to their common multiples, which is LCM basically. Now, the next part is first meeting at the starting point. Now, for this to happen, what you need to understand is how many points they will keep meeting each other. So, if you remember, we talked about A and B. So, A and B are gonna meeting each other in 2 points only. One at 6 o'clock, one at 12 o'clock. A and C, for that matter, will meet in three different points because 5 and 2 ka difference is 3, and those three will be symmetric points. Of course, the last meeting that happens at the starting point, and the middle part, that is B and C. B and C will meet each other in only one point, and that means all of them will meet each other at only exactly one point, for example. And this is how you figure that out. So, three runners or more than three, you have to do two at a time so as to get the idea. Now, secondly, since we have already gotten this answer that overall they are going to meet only once, which is the starting point back again once the race has begun. The other question that we have left now, that is question number 2, which says first meeting at the starting point. Just now we said that there is only one meeting that is happening among all three of them together, which is at the starting point. So whatever is the time taken for the first meeting is ideally the time taken for the starting point also. And if you remember, for the first meeting, they all have taken 140 seconds as the LCM, and obviously, answer will be 120 only. The answer of the first question itself. Because there is only one meeting that is happening at the this is the way to do that. Question number 7, similar backgrounds. The data changes that B and C are moving in the same direction and A moves in the opposite direction. So A moves in the opposite direction, B and C in the same direction. Length of the circumference is changed from 120 to 112 meters. Same three questions. Let's start with the first one, which says, after how much time do they meet for the first time? Clearly, here what should happen is that let's do the individual calculation one more time because there are three runners again. So A and C and A and B, for example. So A and B, the speeds are 5 and 3. The relative speed will be 8. Why? Because A is moving in the opposite direction. So please do not make these mistakes while calculations. 5 plus 3 is 8. 112 divided by 8 becomes 14 seconds. Then what about A and C? So A and C, again, the speeds are there 5 and 2, but they are also moving in the opposite direction. Obviously, relative speed should be added. So 5 plus 2 is 7. 112 divided by 7 gives us 16 seconds for A and C to meet each other every time. A and B meets each other every 14 seconds. Of course, we want to ask all three of them. So clearly, all three of them will also meet each other together as LCM of these two numbers. So 14 and 16 ka LCM is 112 only. So for example, A, B, C, all three of them meet at the first time, for the first time in 112 seconds. And that's the way to do that. This is how you calculate that. And similarly, time taken for the first meeting at the starting point. Now again, for this we need to know how many meetings are happening overall. So for that we need to do the third question. Very interesting. A and B will meet each other in 8 points because opposite direction. And A and C will meet in 7 directions because again opposite direction. So these are the positions. Now if you try and track B and C because they are going to meet only once, and if you see that all three of them are going to also meet only and only once, which is at the starting point. So the idea here is the answer of the second question is as good as the time taken for the first meeting, because once the race has begun, these all people, all three of them, are not meeting anywhere except the starting point. So of course, that's the reason answer for question number 2 is also 112, and answer of question number 3 is 1 point only, which is the starting point, for example. So these are the ways in which you can do circular races. Two players, three players, same direction, opposite direction. Going forward, you should be able to solve such kind of questions. Okay, so that's the whole idea behind it. Now let's do question number 8, which says, after 4 o'clock, at what time will the hour hand and the minute hand of the clock coincide for the very first time? Answer is required in hours and minutes and seconds format. Now here we have to use the formula, that is relative speed upon sorry, that is separation upon relative speed, time taken to minute slash cross wala. But here we have to understand we require the answer in hours and minutes and seconds format. We will also have to do it in. Now, how do we do this? So first of all, the position at 4 o'clock. So at 4 o'clock, this is the position. Hour hand at 4, minute hand at 12. When you understand this, that when do they meet? So obviously the only reason or the only way that they will meet is that minute hand comes down from 12 to 4. That means there is a separation of 20 minutes, or we can say that 120 degrees, because 1 hour is 30 degrees. And if we take the separation in degrees, the relative speed should also be in degrees. And if we take the separation is minute spaces, the relative speed should also be in minute spaces. Now, both these values are going to give you the same answer, that is 240 by 20, because 12 to the 24. So 240 by 11, if you calculate this 240 by 11, you're going to get the answer as 21.9 by 11 minutes. Now there is a small trouble here. The reason being the answer is required in hours and minutes and seconds format, whereas we do not have the answers in second format. And 21 minutes wale there are two answer options that we have. So what we'll have to do is we'll have to convert this 9 by 11 minutes into seconds, for example. Now how do we do that? So obviously 1 minute is 60 seconds. So 9 by 11 minutes is how many seconds, for example. And when you do that, you will get the answer as roughly around 49 seconds. And hence the answer becomes answer option 1, which is 4 hours and 21 minutes and 49 seconds. The minute hand and the hour hand will meet after 4 o'clock. That's the way to do that. Question number 8 for that matter. Let's look at question number 9. It says, what is the smaller angle between hour hand and the minute hand at 9:20? So again, we have to find out the position at 9:20. So hour hand slightly above 9 o'clock, not at 9 o'clock. A lot of people make this mistake. So be very careful. Slightly above 9 o'clock hour hand and minute hand at 4. Because we are calculating the angle, so let's straight away talk about in degrees only. So 1 hour is 30 degree. From 4 o'clock to 9 o'clock, if we consider, then we have around 5 hours. So 5 hours becomes 150 degrees. 30 hours ke 5 hours each. But the hour hand is not exactly at 9 o'clock. It is slightly above 9 o'clock. So let's assume that additional angle as x degrees, for example. But we have to understand this, that this movement of our hand above 9 o'clock is happening because the minute hand has moved from 12 to 4, from 9 o'clock to 9:20, for example. And that is the reason that the hour hand has moved slightly above 9 o'clock. So for this, we need to calculate this angle, and this angle will be calculated. For this, we need to know one concept that we have covered already, of course, but we need to know, and that concept is how many degrees our hand cover every minute. So the answer you will find it something called as speed of our hand degree per minute. So that tells you that our hand covers half degree per minute. Our hand covers half degree per minute. We have written this. Check that table of relative speed. You will get what I'm saying right now. So this means in 1 minute, our hand moves half degree. And here it has moved 20 minutes, the minute hand. So obviously in 20 minutes, the hour hand will move 10 degrees additionally, because 1 minute is half degree. So 20 minutes is 10 degrees. So the additional value of x is 10 degrees, and that means the overall answer is 160 degree, which is answer option 3. The smaller angle between our hand and the minute hand at 9:20 as the position. So that was the ninth question. Let's look at the 10th one, which says there is a watch running 7 minutes behind the time on Monday at noon, and it was running 10 minutes ahead of time next Monday at 2 p.m. If it showed the correct time exactly once the weekend or during the entire week, then on which day and at what time did that happen? So here the clock is 7 minutes behind on Monday at noon, which is Monday 12 p.m. and it is 10 minutes ahead next Monday 2 p.m. First we need to identify from this Monday 12 to next Monday 2 how many hours will be there. So clearly 170 hours would have been passed because Monday to Monday 12 to 12 is 24 hours, 7 days 168 hours. We have to go till 2 p.m. So 12 to 2 is another 2 hours. So 168 plus 2 that gives us 170 hours to be precise. And in those 170 hours, if you track the movement of the minute hand, earlier it was 7 minutes behind. The clock was 7 minutes behind. We can say minus 7 for example. And now it is 10 minutes ahead, which is plus 10. So we can say from minus 7 to plus 10, it has moved by 17 minutes. From minus 7 to 10 minutes ahead, it has moved by 17 minutes. So clearly you can compare now. For 17 minutes, we have traveled 170 hours. So for 1 minute, we have to travel 10 hours because 17 tens are 170. For 17 minutes, 170 hours. So for 1 minute, 10 hours. Now we are saying the clock should correct time once during the week. So now we have like two options basically. So this is what we said is minus 7 and this is what we said as plus 10. So either we can go 7 minutes plus from here or we can come down 10 minutes backwards from here. That is 100 hours because 1 minute is 10 hours. 17 minutes in 170 hours. 1 minute in 10 hours. Or 7 minutes ahead, that is 70 hours ahead. 70 hours ahead from Monday noon. If you do that, you get the answer as Thursday 10 a.m. for example. So the clock showed correct time on Thursday 10 a.m. And that is the answer. Thursday 10 a.m. which is answer option fifth for this particular question. This is what you can do here also. So folks, that is about races, which is your ratio proportion module. Make sure you revise it, go through this one more time clearly. And if you still have any issues or questions or doubts, uh, feel free to let us know. We'll be happy to help. So have a great day. Thank you so much. See you in the next class. Bye bye.